Today we're going to be doing our first set of notes asynchronously, where we're not doing lecture in class. Remember, you do have to submit your notes, so make sure when you're done that you submit your notes to Google Classroom. You can pause, rewind, slow down, or even speed up this video using the functions built into YouTube. Use those to your advantage so that these notes go at the pace that works for you. Today what we're going to be doing is expanding our factoring out into higher order polynomials. And all that means is we're looking at higher degrees. So the first thing we're going to do is we're going to refresh on GCFs. So we're going to consider first the problem 4x cubed plus 6x squared equals 0. So what's the GCF for this binomial? Our GCF, or greatest common factor, is 2x squared. So then we're going to factor that out, 2x squared. Remember, factor out basically means divide, so what we're really doing is dividing all of these terms by 2x squared. That's going to leave us with 2x from the first term, and then plus 3 from our second term, and this is equal to 0. This is factored. We can't go any further with either of our two parts, so we have a 2x squared that we can't factor anymore, and a linear term 2x plus 3 that we can't factor anymore. To solve, we take each of our factors and set them equal to 0. Here we have 2x squared equals 0, and then we have 2x plus 3 equals 0. Our linear factor will give us a solution, negative 3 over 2. Our quadratic factor is going to give us a solution, x equals 0. But because there's a 2 here, if we wanted to, we could make the argument that we could split this into 2x times x, and then we have two factors that are x's. So this gets what we call multiplicity 2. Multiplicity just means that it occurs twice, 1, 2. So if you notice, we have actually 3 factors. We have 2, a 0, and a 0, and a negative 3 over 2. And if you notice, the degree of this polynomial is 3. So this is our factorization, and these are our solutions. We want to get in the habit of whenever we see something like this that has multiplicity 2, or what we might have called in the past a double root, that we notate that. So the question becomes, how can we use this to solve polynomials with 4 terms? So if we have a polynomial with 4 terms or more, what we're going to do is we're going to basically solve this like the grouping that we went over in our quadratic factoring review. So this is very much like grouping for quadratics. In fact, we call this method grouping. Grouping for us means we're going to use a grouping symbol, which is going to be parentheses. So we're going to group terms together. More than likely, for most of the problems we'll see in this class, we're going to group in pairs. You can, however, group in larger groupings if it works for your problem. Sometimes it requires that you get a little creative. So let's look at this first problem. And let's just group our first 2 together and our second 2 together. Now, something important about grouping, what goes in between will always be a plus sign, always. We will never put anything other than a plus sign between our 2 groups. Next thing we're going to do is look for a GCF of each group. In our first grouping, we have a GCF of k squared. So we're going to pull out a k squared. What will be left is k plus 5. Our GCF for our second group is 5, and we pull that out, we're left with k plus 5. You should notice that there's a similarity now between our 2 terms, or our 2 groups. we now have a common factor that's linear. So this linear k plus 5 is a common factor. So we're going to pull that out. K plus 5. Now imagine if we got rid of this k plus 5 in both places, what's left? So what's left is k squared minus 5, and that is our new factor. So we're just taking this linear factor and pulling it out, because if you think about it, if I distribute this whole blue thing in, I would have k squared times k plus 5, which is right here. And if I distribute this whole blue term, this whole linear piece, to 5, I would have 5 times k plus 5. So we're just undoing distribution, which is called factoring. So this is what our factorization looks like. Something interesting to note is that we have a linear factor and we have a quadratic factor. We can't actually factor this quadratic factor anymore because it's a sum and it's a binomial, so we can't go any further than this. So we have a linear and a quadratic, so this is degree 1, remember, and this is degree 2. If we add those up, we get degree 3, which is the degree of our original problem. Do you remember what degree 3 is called? So a degree, and I'm going to abbreviate that deg, a degree 3 equation is called a cubic equation. So cubic is one of our big polynomials that we're going to be studying a lot this year. Cubic meaning degree 3. So the last thing we need to do is solve. Remember, to solve, we're going to take each of our factors and set it equal to 0. So we're going to take k plus 5, set it equal to 0. That's going to give us k equals negative 5. So let's highlight our factorization. And then we have one solution. How many solutions do you think we should expect when we have a degree 3 equation? Well, if we go back, we see that this degree 3 we solved earlier had 3 solutions like we talked about. So we should expect to have 3 solutions for this cubic equation. So let's look at our quadratic term. So our quadratic factor, k squared plus 5 equals 0. We're going to solve this using square roots. We're going to subtract 5 from both sides. Get k squared equals negative 5. And then we're going to take the square root. Remember, whenever we take the square root, you must do plus or minus square root. So in this case, we get the plus or minus square root of negative 5. Hopefully you remember that we have a problem when there's a negative inside of a root. So do you remember what happens when we have a negative inside of a root? So when we have a negative inside of a root, it comes out and it becomes an I. So this is really plus or minus I root 5. So let's rewrite our solutions. So our solutions are k equals negative 5 and plus or minus I root 5. So those are our 3 solutions to this cubic. Let's try our next one. So our next one has a lot of large numbers. It's also not in standard form. So the first thing we're going to do is get it into standard form. I'm going to try and keep my highest degree term positive, just because I find that helpful. So I'm going to subtract 240. There are no like terms on the other side for that. I'm going to add 120q. There are also no like terms for 120q on that side. So that means I just need to write everything in decreasing power order. So we have 90 q cubed minus 180 q squared plus 120 q minus 240 equals 0. you might notice a couple of things, and I'm going to solve this one way. You don't have to solve it the same way as me. So long as you end up with the same answer, everything is fine. You can pull a GCF out at the beginning of this problem, and it's probably in your best interest to pull GCFs out if you tend to forget. When I group, I tend to not pull my GCF out until the very end, just because it doesn't matter. It will matter in other scenarios, like the second group of problems, that you pull your GCF out first. And so if you do pull a GCF out, our GCF is actually going to be 30. I'm going to show you what it looks like if we don't pull that GCF out, just so that you can see that we're still going to end up with the right answer. So let's go ahead and group. So I'm just going to group them the way they stand. It doesn't matter which terms you group together, so long as you group together terms that have a common factor. Sometimes it can be helpful to not group them in their automatic order. So if we look at this first group that has a GCF of 90q squared, when we pull that out, we're left with q minus 2. Our second grouping has a GCF of 120, and so we factor out that, we're left with q minus 2. Remember, factoring out a GCF just means we're dividing. So we're dividing all of these by 90q squared. We're dividing all of these by 120. We got what we were looking for, the same linear factor in both of our groups, q minus 2. So we're going to pull our q minus 2 out. Doesn't matter if you put it in the front or back. And then we're going to put everything that's left. So we're left with a 90q squared from our first group and 120 from our second group. Once we get here, we need to look and make sure that we can't factor either one of these any further. Q minus 2 is just linear. We can't do anything with that. There's no GCF. Then we have 90q squared plus 120. There's a GCF there of 30. Typically we put GCFs out in the front, so we're going to move it all the way to the front. And then if you wanted to, you can flip them, or you can keep them in the same order. Remember, it doesn't matter what order you put your factors in because we're multiplying. So I'm going to move this factor to the front just for myself so that I keep that with the 30. So that's going to go with 3q squared plus 4, and then q minus 2 equals 0. So this is our factorization. Next thing we want to do is solve. So I'm going to make this a little bit smaller so I have more room. Alright, so let's look at our first factor. So we're going to look at 3q squared plus 4 equals 0. First thing I'm going to do is subtract 4. That gives me 3q squared equals negative 4. Then I'm going to divide by 3. And I get q squared equals negative 4 over 3. How do we get rid of a square? We take the square root. Don't forget, whenever we take the square root, we must take plus or minus. So this is q equals plus or minus square root of negative 4 over 3. Now, this might be a review or this might be totally new. I'm going to show you how to do this a bunch of times and we're going to get used to it. For the time being, if you leave your answer like this, it is wrong. You must do at least one step. And that's deal with this negative. Remember, a negative on the inside is going to become an I on the outside. So we have plus or minus I root 4 over 3. Now we need to deal with the square root of a fraction. We do that by taking the square root of the top and the bottom. So this is plus or minus I square root 4 over square root 3. Well, we can take the square root of 4. That's just 2. So we have 2 over root 3. Now there's a problem. We do not want to leave a root in the bottom of a fraction. We get rid of that by doing something called rationalizing. We're just going to take the root on the bottom and multiply it on both the top and bottom. And so we get root 3 times root 3, that's root 3 squared. That square root and that square cancel, and we just end up with 3 on the bottom, and we still have plus or minus I out front, and then we get 2 root 3 on top. So it's a little bit complicated and a little long, but the more you practice it, the easier it's going to get. Then we just have to solve our other factor, which is our simple linear factor, which is q minus 2 equals 0, and we just get q equals 2. So our solutions are q equals 2 and plus or minus I 2 root 3 over 3. Take a second and pause this video and try 3 and 4 on your own. Make sure you try them on your own and then come back to check your answers so you get some practice time by yourself. For number 3, we need to make sure it's in standard form. So we're going to subtract 50. There is a like term with 20, and then we're going to add 3x, which is going to get combined with this 12x. So after we combine like terms, we end up with 3x cubed minus 6x squared plus 15x minus 30 is equal to 0. Let's go ahead and just group our first two and our second two. Again, you can group differently if you like, just so long as they have a common factor. Now we need to identify our GCFs. For our first pairing, our GCF is 3x squared, and we're left with x minus 2. For our second pair, our GCF is 15. We're left with x minus 2. We got what we needed, a common linear factor of x minus 2. So we're going to pull that out to the front. X minus 2, and we're left with 3x squared plus 15. Remember, we get that by basically just erasing our common factors. Literally what is left, that would be 3x squared plus 15. Equals 0. Now we need to double check. Can we factor any further? And the answer is yes. 3 and 15 have a common factor of 3. So let's put that out front. 3. What we'd be left with was x squared plus 5. Then we still have our x minus 2 factor. And now we can't factor any further, so let's put that in a box. This is our factorization. Now we're going to solve. Remember, to solve, we're going to take each factor. And notice I didn't underline the 3. If we take this factor and set it equal to 0, we get 3 equals 0, which is not true. It doesn't give us a solution. It doesn't provide any meaningful information, so we can just basically ignore it unless it has a variable with it. If it's just a number, we don't need it. So then we have x squared plus 5 equals 0. Subtract 5, and we get x squared equals negative 5. Take the square root. Remember to do plus and minus. Get x equals plus or minus the square root of negative 5. Remember that negative is going to come out. And so this is really x equals plus or minus I root 5. Our last one, we deal with this linear factor, x minus 2 equals 0. Add 2, we get x equals 2. So our solutions, I'm going to rewrite them, are x equals 2 and plus or minus I root 5. If you haven't finished number 4 or taken the time to try it on your own, go ahead and pause the video and do that now. If you've already tried it on your own, you can keep watching. The nice thing about number 4 is it's already in standard form for us. So let's just group. Let's try and group in a different way than we have. So let's group first and third. X cubed minus 9x. Plus, remember it will always be a plus in the middle. Let's group our second and our fourth together. 2x squared minus 18. If I take my GCF of my first pair, that's going to be x. So we get x, and we're left with x squared minus 9. For my second group, my GCF would be 2. I'd be left with x squared minus 9. So if I group this way, my common factor is actually quadratic, and that's fine, just as long as it's the same. Let's use green. X squared minus 9, x squared minus 9. So we're going to pull that out, goes out front. X squared minus 9, x plus 2 equals 0. Are we done? Is this factored? Hopefully you see that it's not. If we look at this quadratic term, this is a difference of squares, which I'm going to abbreviate DOS. So we can continue to factor this. 9 is really 3 squared, and so this is actually going to factor into x minus 3, x plus 3 times x plus 2 equals 0. This is actually a really nice factorization because this cubic, remember cubic means degree 3, this cubic factors into 3 linear factors, which makes solving for us much easier. All I have to do is change the signs. Instead of negative 3, I have positive 3. Instead of positive 3, I have negative 3. Instead of positive 2, I have negative 2. So the nice thing about this one is all of our solutions were integers. So this is what factoring by grouping is going to look like. More often than not, we are looking for when we have 4 terms in standard form to use factoring by grouping. We're going to go over one other factoring method today, and that's substitution. So my question for you is, what is substitution? What does that mean? So substitution is all about replacement. Think about substitute teachers. You can sub someone in sports. You sub someone out. So we're replacing one thing for another. So what does that mean when we're talking about factoring? What are we going to replace and what are we replacing it with? And oftentimes, for us, this is replacing powers. Basically, we want to find a way to rewrite high powers with low powers. And so what we're going to look at today is how we can turn a quartic, or degree 4, into a quadratic. So we're going to take a quartic, which is degree 4, and turn it into a quadratic, which is degree 2. I understand that's confusing, that quad, which you would think of as 4, is for degree 2. And at the moment, I do not have an answer to you as to why that is. But quartic is what we use. You want to think like quarter, or a quart, like measurement, is for 4. So we're going to try and take our degree 4s and rewrite them as degree 2s. How do we do that? Well, we do that using the fact that x to the 4th is really x squared squared. If you remember our exponent rules, power to a power we multiply. So let's look at some examples. So if we're looking at number 1, we have x to the 4th plus 36 equals 13x squared. Problem number 1, it's not in standard form, so let's go ahead and subtract this 13x squared to the other side. Once we do that, we end up with x to the 4th minus 13x squared plus 36 equals 0. This is a really common substitution problem where we see an x to the 4th, an x squared, and then a constant. This should look familiar. It almost looks like, if let's just call it y instead, looks really similar to something that might look like this. And this is nice, right? We can solve this. It's a quadratic with a leading coefficient of 1. It's our most basic, really quadratic trinomial. So how do we make this into this? Well, we're going to use substitution. And so we're just going to say, we're going to let x squared be equal to y. And so if we do that, let's actually use a different color. Let's use orange. So I'm going to use this little statement, and I'm going to rewrite this as x squared squared minus 13x squared plus 36 equals 0. And so then I'm going to replace all of my x squareds with y. And so when I do that, I get y squared minus 13y plus 36 equals 0. So I get exactly what I was talking about before. I don't always write this step out, and you don't have to either. If you can just remember that when we have a fourth and a square, we're just going to pretend it's quadratic for a little while and change that variable. That's basically all substitution is. So let's go ahead and factor this quadratic now. So we're looking for factors of 36 that add up to negative 13. So that's going to be negative 9 and negative 4. So factoring this quadratic looks like y minus 9, y minus 4 equals 0. Factored. Now, remember, y is not our original variable. X is. So we now have to resub it in. So everywhere there's a y, we're going to put x squared. So we get x squared minus 9, x squared minus 4 is equal to 0. Are we done? Is this factored? So the answer is no. Both of these quadratic factors are difference of squares. 9 is 3 squared and 4 is 2 squared. Watch out, you are more likely than not going to miss if that's a 1. So don't forget that x squared minus 1 is also a difference of squares. This is the one we tend to miss most often. So our final factorization, and I'm going to make this a little bit smaller so I have some more room. Final factorization is going to be x minus 3, x plus 3, x minus 2, x plus 2. How many solutions are we going to get for this degree 4? We're going to get 4, right? In fact, we get 4 really nice integer solutions because all of our terms in our factor are linear. And so when we split this up, we get 3, negative 3, positive 2, and negative 2. So we get 4 solutions for a degree 4. Hopefully you're starting to notice that there's a very distinct pattern between the number of solutions we get and the degree of our polynomial. We'll talk more about that later, but that's something called the fundamental theorem of algebra, and it will always hold true. So with that in mind, how many solutions do you expect we're going to get for number 2? Well, since it's degree 4, we should expect 4 solutions. That degree tells us how many solutions we should expect to get. It doesn't mean that all 4 of our solutions are going to be nice or real, it just means there are going to be 4 solutions. So we're going to follow the same strategy as last time. Instead of x to the 4th, this is x squared squared minus 81 equals 0. Now we're going to pick a new letter. It doesn't matter what you pick. I'm going to pick G this time. So I'm going to let G be x squared, and then this becomes G squared minus 81 equals 0. Now this new quadratic I have is a difference of squares. This is really 9 squared. So then I write out my factorization. I have g minus 9, g plus 9. Now I need to go back to my original variable. Don't forget to go back to your original variable. Our original variable is x. So instead of g, I'm going to write x squared. This is x squared minus 9. X squared plus 9. Hopefully you're seeing we have that same difference of squares we saw last time. This guy is a difference of squares. So we factor one more time. X minus 3, x plus 3, because 9 is 3 squared. So we have x squared minus 3 squared. That's how that factors. And then we still have x squared plus 9. It's only difference of squares that factors, so this sum of squares is not going to factor. Some of you who are thinking ahead and might notice that, could we factor that? I mean, technically we can, but we don't factor it in the traditional sense of using real numbers. We can factor it using imaginary numbers, but it's not traditionally something we do when we look at factorizations. So we're just going to leave it like this. So this is our factorization. Now let's look for our solutions. Our first two solutions drop out pretty easily. That's 3 and negative 3. Remember we said we're expecting 4 solutions, so we are expecting 2 more. And it makes sense that this degree 2 factor will give us those 2 other solutions. So let's set x squared plus 9 equal to 0. We're going to subtract 9. Then we get x squared equals negative 9. Take the square root. Remember, whenever we take the square root, we are supposed to do plus and minus. Negative inside comes out and becomes an I. So we have plus or minus I square root of 9, and the square root of 9 is just 3. So this is just 3I. And remember, if we have plus or minus, we can write that out as 3I and negative 3I. That's what plus or minus is. It's just a shorthand way of writing a positive and negative. So we can actually rewrite this much shorter as plus minus 3, plus minus 3I. It doesn't matter to me which way you write it, but you do need to understand what both of these lines mean. You can either choose to pause now and try the next one on your own, or you can go through the next one with us and then try 4 and 5 on your own. But make sure you try at least 2 of these by yourself and then check back in. So looking at number 3, the nice thing about it, it's already in standard form. Everything is already moved to one side. However, we do have a leading coefficient this time. That means we need to use one of our methods. I'm going to go through slide and divide just because I like that method and sort of that strategy. We're also going to go ahead and substitute. I'm going to substitute a little bit faster this time to show you what I would write out. So I'm just going to know that this is going to become my square term. I'm going to use the variable b. So we have 9b squared plus 45b plus 14 is equal to 0. So now we're going to take our first and our last, and we're going to multiply them. 9 times 14 is 126. So we're looking for factors of 126 that add up to 45. So you might have to do some guessing and checking here, but it's going to be 42 and 3. Next thing we need to do is divide. And we always divide by what we slide, which is this first coefficient. So we're going to divide them both by 9 and simplify. When we simplify 42 over 9, they're both divisible by 3. That's 14 over 3, and this one simplifies to 1/3. My denominator goes in front, my numerator goes in back, and we write out our factors. Remember, my variable I'm using right now is b, so this becomes 3b plus 14, 3b plus 1. Now I need to go back. I need it in my original variable. So we need our OG variable. But it's always going to be squared when we're dealing with x to the 4th. So when I put this back in, I get 3x squared plus 14, 3x squared plus 1 equals 0. So this is my factorization. The most common mistake people make when we're doing substitution is forgetting to go back to our original variable. So make sure that you do this. Now for this one, our solutions are going to be kind of gross. They're both going to be imaginary and irrational. Irrational meaning we're still going to have a square root left when we're done. So we're going to go through these kind of slowly. Let's look at our first one. So we have 3x squared plus 14 is equal to 0. So we're going to subtract 14. Whenever we get to this part where we have a square by itself on one side and a negative on the other side, that should be an indicator that we're going to be having an imaginary solution or an I. Next we're going to divide by 3. To get rid of our square, we take the square root. Don't forget to do plus or minus, that's super important. So we get x equals plus or minus the square root of negative 14 over 3. Let's go ahead and take that I, that negative, outside. Get plus or minus I, and then we're going to split our fraction, numerator, denominator. Square root 14, square root 3. Now we need to rationalize. So we're going to multiply our top and bottom by 3. And so when we do that, we end up with plus or minus I. 14 times 3 is 42. 3 times 3 is the square root of 9, which is just 3. So that's our first solution. Let's do our second one. So we have 3x squared minus plus 1 equals 0. We're going to subtract 1, divide by 3, take the square root, make sure you do plus minus. If we take the negative out and split, we get the square root of 1 over the square root of 3. To get rid of our square root, we have to multiply it on the top and bottom. And so what we're going to end up with for this one is plus or minus I. Root 1 times root 3 is just root 3. In the bottom we just get a 3. So our solutions are plus or minus I root 42 over 3 and plus or minus I root 3 over 3. This is definitely a lot more work when we have these imaginary solutions and we have to rationalize, but we want to get used to it and sort of really develop this skill this year. If you haven't already, take the time to pause this video, try 4 and 5 on your own, and see how far you can get before you come back. Looking at number 4, we need to get it in standard form. I'm going to move 2 terms as opposed to moving 1, so I can keep my leading coefficient positive. I'm going to move both of these terms to the other side. So it's going to be 4p to the 4th minus 14p squared minus 8 equals 0. Here's where it's important. You need to take out your GCF. You should notice that all of these numbers are even, 4, 14, and 8. That means we can at least take out a 2. So when we do that, we're left with 2p to the 4th minus 7p squared minus 4 equals 0. Okay? For this particular problem, I'm actually going to do it without ever writing down my substitution. Hopefully you already did this on your own so you can sort of see where this comes from. This is an alternative way to do it. If you need to write out the substitution, please do, but it's not actually required. So let's go ahead and we're just going to pretend it's quadratic and solve, because that's basically what we do when we do substitution, is we're just pretending it's quadratic, we're just writing it out. So leading coefficient, multiply, gives us -8, so we're looking for factors of -8 that add up to -7. It's going to be -8 and +1. Then we need to divide, and we divide by what we slid in, which was 2, or our leading coefficient, and simplify. That gives us -4 and 1/2. Then we put it in, denominators go in front, numerators go in the back. If it's just a number, it just goes in. Now, when I factor, I'm just going to remember, if you notice, whenever we get these factors, like right here, they're squares instead of just x. They're squares instead of just x. They were squares instead of just x. So when I factor this one, instead of just p, let me use p squared. P squared minus 4. This one is going to be 2. P squared plus 1. Don't forget, if you have a GCF, to pull it down. So we also have this 2 in front. This is one way to do it. You don't have to do it this way, but if you're starting to see that this is how it works, you are more than welcome to just write out this much. It's up to you how much you need to write out and how much you need to do for each problem. Just make sure you understand the process. If you need to go back and work through all of the steps, that is a perfectly valid approach. Don't feel like you're behind or anything like that. Do what you need to do. It's your work. We do have a difference of squares. So our factorization is actually 2p minus 2p plus 2, because we have this difference of squares right here. And then we still have our factor 2p squared plus 1. So this is our factorization for this problem. Let's make it a little bit smaller. All right. Our two linear factors give us solutions fairly quickly. 2 and -2. Remember, this is quartic, or degree 4, so we expect 4 solutions. Excuse me. Next thing we need to do, we need to take our quadratic term, 2p squared plus 1 equals 0. Subtract 1. Divide by 2. Plus or minus square root. Take your negative outside. Split your fraction. Then we need to rationalize our denominator by multiplying it to the top and bottom. Hopefully you're also realizing that when we multiply it times itself, we're squaring it, which is why that square root goes away. And so we end up with plus or minus I root 2 over 2 for our last two solutions. Hopefully you've tried number 5 on your own. We're going to go through this one pretty quickly to show sort of how fast we can actually make these problems as we really get used to this process. First thing to note, we have a negative leading coefficient. I'm going to factor it out. Instead of moving everything to the other side, which if we're just solving is okay, I want you to get used to factoring out GCS instead of dividing them out and getting rid of them. Because when we're working with functions, we don't want to just drop them. So when we factor that out, we have negative t to the 4th plus 7t squared minus 18 equals 0. Now we have a nice leading coefficient of 1 inside. So again, I'm going to pretend it's quadratic. I'm going to play pretend. And so I'm just going to look for factors of negative 18 that sum to 7. And so those are going to be 9 and -2. And then I'm just going to make sure that when I write out my factorization, I use a square. So we have a negative, we have t squared plus 9, t squared minus 2. This is a square, yes, but this is a sum. So this is a sum of squares and thus does not factor. This is a difference, but 2 is not a sum, or not a square. So this does not factor as well. So that's as far as we can go. This is our factorization for this one. So much fewer steps than our last ones. Next thing we do is solve. So we're going to take t squared plus 9 and set it equal to 0. Subtract 9. Take the plus or minus square root. Negative becomes an I on the outside, and then we have the square root of 9, which is just 3. Now, I3 is weird. We don't normally write it like this. We normally write it as 3i number in front. Is I3 technically wrong? No, it just looks weird. So that's our first solution. It's actually our first 2 solutions. Remember, we're anticipating 4 because of our degree. To take our other one, we have t squared minus 2 equals 0. Add 2 to both sides. So we have a square equal to a positive. That should indicate that this is going to be at least a real number. Take our plus or minus square root, and we get plus or minus the square root of 2. Remember, this is called an irrational number. It never stops. If we put this into our calculator, we would get a bunch of digits, and really there are an infinite number of them that our calculator actually can't even calculate. It has to give us an approximation. So we normally write it like this instead of as a decimal because this is what we call an exact answer. We haven't done any rounding to change our answer at all. Square root 2 is an exact number, even if we don't know what it really is. So those are our 4 solutions for number 5. And just as a quick reminder, you can rewrite all kinds of different powers. You just need to remember your exponent rule. Power to a power, we multiply. If you want to see that written out, that looks like x to the a to the b is equal to x to the a times b. So let's look really quickly at a couple different sort of higher powers that might be useful for us. If we have x to the 8th, we could rewrite that as x to the 4th squared. We could also write it the other way, x squared to the 4th. If we have x to the 6th, we could write that as x cubed squared, or write it as x squared cubed. We could do this with all kinds of different powers. X to the 9th is x cubed cubed. Basically all we're doing is factoring 8. 8 is 4 times 2. 4 times 2, we can write it in either order. Okay? That's all for these notes. Make sure that you've submitted your completed notes to Google Classroom once you're done.